Today on Softellar Tech Briefs, we're looking at software testing across the testing pyramid, from unit tests through end-to-end validation, and the complementary approaches that help teams deliver reliable software. Today, we'll explore the hierarchy of testing approaches and why different testing levels matter for building robust, dependable products. Understanding the testing hierarchy. Software testing follows a hierarchical structure known as the testing pyramid. The pyramid represents how tests are distributed across levels, with the bulk of testing focused lower down and fewer tests at the higher levels. The three primary levels are unit testing, integration testing, and system or end-to-end testing. Unit testing sits at the base. Individual components or units of code are tested in isolation. These tests verify the correctness of small, self-contained units such as functions or methods. They help identify bugs early and confirm that each unit behaves as expected. Teams typically use unit testing frameworks and tools to automate this work, so errors are caught early in development. Moving up the pyramid, integration testing examines interactions and compatibility between different units or modules. The goal is to confirm that integrated components work together smoothly and preserve expected functionality. Common techniques include top-down, bottom-up, and sandwich approaches, which help validate that modules integrate correctly. At the top of the pyramid is system or end-to-end testing. This level assesses the overall behavior of the complete system as end users would experience it. System tests verify that the software functions as a whole, including interactions among modules, databases, networks, and user interfaces. Through end-to-end testing, teams confirm that the product meets specified requirements and performs as expected in real-world scenarios. Additional testing approaches and techniques. While the testing pyramid provides a general framework, other approaches complement that hierarchy. Acceptance testing validates whether the software meets the requirements and expectations of end users or stakeholders. It helps confirm readiness for deployment and use in the intended environment. Regression testing checks that changes or additions do not introduce new defects or break existing functionality. By retesting previously covered features, it helps maintain overall quality and stability. Performance testing assesses responsiveness, scalability, and stability under varying workloads and stress conditions. It helps identify bottlenecks, measure system performance, and guide optimizations for a smoother user experience. Security testing aims to find vulnerabilities and weaknesses that could compromise the application. Techniques such as penetration testing, vulnerability scanning, and code analysis help reduce security risk and protect sensitive data. A practical approach to testing. A strong testing process typically includes several connected steps. Test planning and strategy. Teams develop a test plan that outlines objectives, scope, and approach for the project. The strategy should reflect specific requirements, risks, and constraints of the software under development. Test case design and development. Experienced testers design cases that cover relevant scenarios and functionality. Both manual and automated test cases help ensure thorough coverage and efficient execution. Test execution and defect tracking. Testers run the cases, record results, and track defects in a reliable defect tracking system. Close collaboration with developers helps resolve issues in a timely way. Test automation. Automation plays a major role by handling repetitive and time-consuming tests. Industry-standard frameworks and tools can shorten cycles and make testing more consistent. Continuous integration and continuous testing. Adopting continuous integration and continuous testing practices helps execute tests consistently throughout the development lifecycle, so issues can be found and addressed earlier. Closing takeaway. Software quality depends on testing at multiple levels, from foundational unit tests through integration and end-to-end validation, supported by acceptance, regression, performance, and security testing where needed. Combining automated and manual techniques, following clear plans, and keeping quality visible throughout the development lifecycle helps teams deliver more robust, reliable software. If you'd like to learn more about software development, AI, cloud, data engineering, and digital transformation, visit us at softellar.com.